Topic 28, DNA, RNA, and protein. Here are our objectives and intro video. So here we're going to be looking at how messenger RNA, ribosomal RNA, and transfer RNA are involved in the transcription and translation of genes. We do shorten those to mRNA, rRNA, and tRNA. We're going to talk about how the role of RNA polymerase is in the synthesis of mRNA, so meaning how mRNA is made. And we're going to describe how the code of DNA is translated into the message, the mRNA, and then eventually to make a protein, because that's what we're trying to do. Intro videos here, script, objectives, video, due date. All right, assignments here. We have a video forum. We have our study guide, like always. Help form if you need it. And then we have an added assignment. We have the transcription and translation activity. I want you to review the following resources, which we'll see in a second. Base pairing rules, DNA, RNA, protein example, regular codon chart, and circular codon chart. Of course, read through those instructions and watch the videos to help with this assignment. I definitely recommend that. All right, so let's go ahead and look at our notes located here, vocabulary and additional readings. We'll go ahead and hit the next button. Notes, you can click here or click within here. Same for the vocabulary here or click here. Additional readings, we have quite a few. We have central dogma, RNA, transcription, genetic code, translation. So these last three are pretty big to help you with your big activity as well. All right, so your first graded assignment is the video forum. There are 3 videos located here. 5 points, take me about 35 minutes to complete. This one is on Crash Course, DNA, transcription, translation. Here is the Amoeba Sisters, DNA versus RNA. And then here's a pretty important one right here, guys. This is the protein synthesis. This walks you through actually how to complete your activity. It does help. Next, we have our study guide, 13 points, take you about 30 minutes, instructions, audio, and then here are 2 questions you need to answer. I've included this, and it kind of helps you right here figure out the answer, because that will help you specifically with 4 and 5. I did include the rectangular one as well. You can use either one, and then you do have some questions down here. Yeah, if you read through this, it does help you. All right, there's our help forum, and then we have some additional things to help you. So I've already showed you the DNA to DNA, but when we make the jump from DNA to the mRNA or the message RNA, you will notice there's a change. RNA does not have T's, they have U's. So just like here where the T was, it's now a U. And anytime we deal with, again, RNA, there are no U's, or no T's. There are no T's. There are only U's. So back here where you see the T's for DNA, you do not see them here. For RNA, you will see U's. And here you can see. So you will be coding where I will give you a 3-base code in mRNA, and I say, tell me what it is in tRNA, and you need to use this to kind of help you out. Again, this just kind of shows you what I did. I went from DNA to DNA, and then we did transcription, which is taking the DNA and creating the message. Here you can see T went to A went to U. Remember, no T's here. T's and G's are always back and forth. And then translation is where we take our message and we find the amino acids on that codon chart. It can be the circular one or the rectangular one. We're going to look at those in a second. And then we need the tRNA, the transfer RNA, to bring us the amino acids. So here you can see those letters matching, okay, or opposite. And then there's a regular codon chart, and again, there's the circular one. You can use either one. With those 4 resources that I just mentioned, here we are at the transcription and translation activity. 20 points. Should take you about 45 minutes or so to complete. Please watch this video here. I explained how to do it. And then the document is located here as a Google Doc. All right, well, that concludes topic 28, DNA, RNA, and protein.